stripped off.
I had very huge line.
Okay, folks, it's time to get started. So gather round the sides of the walls because you're all going to have to speak. Okay. Right. Okay. If everybody's finished talking. Right. Welcome to TechMeetUp. Thank you all for coming. We put it on so you can turn up and be educated and entertained and all the usual sort of stuff. TechMeetUp wouldn't exist if it wasn't for the kindness of our sponsors, who are Skyscanner, Cultivate, and Informatics Ventures, and you are drinking and eating their largesse. If the fire alarm goes off, and I have no idea what it sounds like, go out that door there. More people die hanging around waiting to see if it really is a fire alarm or looking to see where the fire is than actually get caught by accident. So go out that door and make an insurance claim, and Skyscan will no doubt overcompensate you for the stuff you lose. How many people have not been here before? Stick a hand up. 1, 2, 3, 4, 5, 6, 7. Okay, usual sort of percentage. I expect half of you won't be back because it isn't what you expect. Because that's the way it is. If everybody who came who was new stayed, we'd need a bigger room. Quite often. So if it isn't what you thought it was, please tell us what you were expecting. Because without the feedback, we don't know. We have a Google group which is called TechMeetUp where you can post in. There's a Twitter account which is TechMeetUp, and there's an email address which is Edinburgh@TechMeetUp if it's working. Okay, find some way of telling us. Even a carrier pigeon. Leave a note at the reception. Okay, tonight we've got 2 speakers. Our first speaker, whose subject I can't remember because I've been busy.
Desktop Linux.
Desktop Linux, yes. Second speaker is Paul, who will be on Dockerizing, continuous integration and deployment. He's not here yet. He'll be here sometime after 8. So, after the introductions, where you all say a little bit about yourself, we'll have announcements. So if anybody's got an announcement, come up after the introductions and then make your announcement. Don't make it too long because people just get bored. Okay, start there and just say a few things about yourself and what you're interested in. If you're only here for the beer and pizza, say, I'm only here for the beer and pizza. We don't care. I'm not paying for it. Well, I do pay for it, but I get the money back. Skyscanner people are paying for it. Okay, I am Douglas. I know almost all there is to know about barcodes, and that's it.
Sean Derulo, I'm just about to give a talk.
My name is James Master. I'm a developer who works on Open Tech Counter. If anyone's got any recommendations for good managed hosting, that'd be good to hear.
I'm Alistair. I'm primarily here for the beer and pizza at first, and
Fine.
see what comes of it.
My name is Sai. I'm freelance IT person, whatnot. Here for the talks, beer and pizza.
I'm Tamaya. I work in asset management, enterprise risk. I don't really do much to do with technology. I own a SharePoint site, and I'm just here because I'm interested in technology.
Okay.
I'm Christian, currently working at my dashboard and here to find out more about tech.
I'm Daniel. I'm an HPC systems administrator and I run Fedora 23.
I'm Brian. I work for the University of Edinburgh as a researcher.
I'm John. I'm a data scientist here for talks.
I'm Roy. I was studying in Functional Medical Visualization System, TMBS, but I'm leaving there just for today, so I'm looking for any potential opportunity.
Hi there, I'm David. I'm a cloud developer. I'm interested in both talks today.
I'm Rachel. I kind of occasionally help run this event. I've also worked for myself, and I'm looking for opportunities to do talks, presentations. So if you want to meet up like this and you're running, you need a speaker on anything tech related, come have a chat with me. I might have a talk that's good for that, and I want to practice.
I'm Dave. I worked for Sun Life a long time ago. I used to write code, but now I'm a delivery manager. I'm looking for ways in which technology can help us deliver faster.
I'm Thomas. I'm a part-time lecturer at Nature. I'm a physician, code engineer. We do web developing. If you have any questions for us,
I'm Craig. I'm a software developer. I'm not here for the talks.
I'm Chris. I'm a software developer. I work in JavaScript and Ruby.
I'm Rob from the Edinburgh and just here for the talks.
I'm Andrew. I am an entrepreneur interested in game design and Bitcoin related stuff. Web development company. We're looking for someone who can help out for about 8 months. So like, if there's any web developers who are working on projects,
I'm Andrew. I'm an engineer at a startup called Javi. We spun out and before Andrew Brothers.
my name is Ryan. I'm an Android developer primarily. Same company. And just come to check out what's going on.
Alex, Skyscanner, which is downstairs with the
and I'm a Python dev.
I'm Daniel. I'm here as well. Hotels, mostly Python, Docker. My name is again.
I'm Jonathan. I work at
I'm Chris. I'm .NET, JavaScript, full stack web developer.
Hi, I'm Michael. I'm a software engineer at GD Group. We are currently looking for apprentices, so if anyone's interested, please come talk to me. For those who cannot see me, I have a t-shirt that says, "We are here to drink your beer." So that's one of the reasons why I'm here.
Hi, I'm Nam. I'm looking for a role in data warehousing, data science, or R programming.
Hi, I'm Martin, and I'm a graduate student in the University of Edinburgh, and if you have any interesting opportunities,
Hi, I'm Dougie. I'm a software engineer. I'm here for the talks.
Hi, I'm Chris. I'm a full stack Linux engineer. I'm a contractor, so if you want to pay me to do work, come.
Hi, I am Valdez. I'm an informatics student in Edinburgh University, here for networking and clubs.
Hi, I'm Archie. I run a couple of different teams in the Amazon Development Centre Scotland, which is just over in Waverley Gate. As ever, we're hiring. Come talk to me. Machine learning, software development, Java, Python, front-end web, etc. And here for the
Hi, I'm Lina. I'm a student at University of
Hello, I'm Carlos. I'm a student here. I'm here for the talks and here.
Hi, I'm Alistair, Space Gunner. I'm building a migration entirely from data centers to AWS at the moment, which is keeping me busy. Maybe we can meet up until one day. But yeah, we're hiring across the board, especially people with the distributed systems expertise and AWS expertise and skills.
Hi, I'm Matteo from Skyscanner. I also organize a conference called March of the Droids, which will be here in Edinburgh the next Saturday, Saturday the 19th of March. Tickets are still available from marchofthedroids.co.uk. This year our keynote speaker is Steve Comdick of Cyanogen, who's flying in Seattle. As well as Cyanogen, we have Amazon, Free, Huawei, and other good talks lined up. So check out marchofthedroids.co.uk.
Hi, I'm Niall. I'm an Android developer for a company called Bitwink, and also produce an app called My Bus Edinburgh in my spare time. At Bitwink, we are currently looking for Android developers, so if anyone is interested, let me know.
Hi, my name's Jamie. I'm a lawyer. I work at firms sort of specialising in startups, tech startups. I'm interested in this sort of things.
Hi, I'm Michael. I'm a second year student at Napier and a member of the Napier Developers Society.
Robert, I do really like hardware interfacing.
Hi, I'm Alan. I'm from University of Edinburgh Economics Ventures. I'm part of business development. I've done interesting before.
Hello, my name is Neil. I'm a full-time student at Napier. I'm also a part-time software engineer for Blue. We're hiring. We need 11 people, all kinds of people. And I'm here for I'm Steve and Paul.
I'm Gareth. I'm third year student in software engineering at Napier. I'm also the secretary of the Napier Developers Society.
And I am a first year software engineering student.
Jack. I'm a second year software engineering.
I'm Monica. I'm a master's student for computing at TechMeetUp and I'm freelance.
I'm Kyle. I'm president of the Native Development Society. If you want to sponsor us or come on the tour to our students, you can do like that. Yes.
Hi, I'm Greg. I'm a fourth year student at Edinburgh University. I'm studying computing and I'm just learning about law.
I'm Rick. I'm an older student at Edinburgh as well. I'm also a contest speaker and did the UI test.
Good evening, my name is Stephen. I work for a company called Season 7. We do mobile GIS management solutions, that sort of stuff, cross-platform mobile stuff. I'm very honest with you, I didn't even look what the forms were tonight. It just came along.
I'm Russ. I'm the founder and director and Apple developer of Cosmic Lab, and we're currently looking for C developers and network engineers. So if you want to have a chat, just come speak to me. Cheers.
Hi, I'm Chris. Working marketing, just different talks.
I'm Alex. I'm an Android developer at Design. I'm interested in Android architecture.
Hi, I'm Daniel. I'm a web developer at Syracuse Arts.
Hi, I'm Ignacio. I'm from Spain. I'm a telecommunication engineer, and I came because he Mario recommended it.
Yeah. Yeah, my name is Marius. Yeah, for the talks mostly. They haven't shared the schedule, so came anyway.
I'm Tim. I've got a background in AI research and software development. Currently taking some time out to develop some new ideas in the intersection of artificial life, deep learning, and the web. And I'm here because I'm a long-time user of KDE and Kubuntu, and I really want to listen to John, and also interested in Docker as well.
I'm Alistair. I run a firm and we do discrete combinatorial optimization for money, which is fun. And we've just closed a round of funding and we're looking for someone who's experienced in C# or SQL Server. So if that sounds like fun, which it might be, then come and speak to us.
I'm Andy. I'm his subordinate. I write logistics software using artificial intelligence to make people's work more efficient and to help people fire people.
I'm Tim. I'm a scientist at Toshiba Medical. My interest is everything visualization and graphics. What got me down here is the hope someone's going to persuade me this year is the year of Linux on the desktop.
Who would do that?
It's called Remix. People in the middle.
I'm a student at Edinburgh Uni, and I'm just here for the talk today. Yeah. I'm Diego. I work with data. I'm here for Dogger, but also for Linux.
I'm Aaron. I'm a PhD student at Harvard Uni, just basically making tools and stuff.
I'm Alec. I'm a second year student at Laker, just at CSF.
I'm Talia, third year computer science student at Harvard, just to try blockers.
I'm Raymond, Doctor of Biophysics, Energy Systems, Production Systems.
I'm a software engineer here at Skyscanner.
I'm Monica, I'm a programmer at Skyscanner, and I'm here because my book is
Hi, I'm Matt. I'm also a software engineer here at Skyscanner. I came because, well, I stopped my job and, it was downstairs.
So I'm Hugo. I'm Monica and Nathan's colleague. I came this week or this month because you went on meetup.com and I would have come several months earlier if I had known. I also came.
I'm Andrew. I also work at Skyscanner. I'm the Cisco sub.
Okay, I think that's.
I'm Sri. I work at Skyscanner with this teacher. I'm mostly working on
Okay, that's it. Okay, it's going to be a 10-minute break so you can get a drink. Oh, sorry, announcements. Have you got any announcements that we think we should know about?
I do.
Go ahead.
I just started the Lunch and Learn talks at Codebase in the Argyle House, the big rootless building in Westport. If anybody has an interesting lunchtime talk that they think they want to practice a talk or they want to give a talk to the audience at Codebase, which are all startups, then let me know.
We just changed tack to the first one. For those of you interested in coming to March of the Droids, we have a secret page, which is marchofthedroids.co.uk/secret, where you can get discounted tickets. And it has animated GIFs, so it must be good.
Is that it?
That's it, thank you.
Is that for anybody else got an announcement? Right, you have 10 minutes to have a ciggy, have a wee, get another drink, and then we'll be going on with the first talk. Don't sit at the tables. Not to say that earlier.
From experience.
Yes.
Yes. Yes. Speak to the Yabby guys.
Oh, right, okay.
Speaking to a standard life guy.
Oh, yeah.
Well, I've been in that area for I was speaking to
it's gone the wrong way.
William Latham, I don't know if you yeah, right, yeah. So yeah, I saw that. Yeah, actually, yeah, it was built as new. To be honest, I was a bit disappointed. I was expecting something, and it was. And it was actually blown up, slightly lower the resolution, but it was. Anyway. But so I've been in and out of academia, and I've been doing well. The last actually, most of the last 10 years, I've been away from this kind of stuff, and I'm just getting back into it. I'm on the board of the International Society. So I'm kind of getting involved in going to some conferences again. Now I'm trying it. Yeah, as I said, I'm interested in what you can do with modern technology. Doing web-based
Well, Forest is yeah, well, I'm just finishing off a review paper actually about the history stuff. But I think, yeah, you can probably do stuff Oh, that's interesting. So have you done any, have you tried any of that kind of Cousins, yes, yeah. Right, yes. Right. Yes, yeah, right. Yeah. Right, well, yeah, that's... Yeah. That's certainly evolution is certainly for me. Oh, yeah. I'm not sure if that's right. Yeah. It's pretty exciting. It's really just step up in the computing power doing this GPUs. It's really a step up Right, brilliant. I've never used right. Yeah, sure. Yeah. Sure. Yeah. Right. Well. Right. Yeah. That's
Right. Right. Okay. Sure. Right. Have you come across Craig Robertson? Maybe not. I don't know. Craig Thompson used to. No. Okay. Right. I will speak to you.
Okay, folks, it's time for the first talk. Take a seat.
all day.
Really? Right. Okay. We'll be glad to know our second speaker has turned up, so you don't have me doing one of my talks again. So we will have the first speaker, Ubuntu Desktop by Paul, International Freedom Fighter.
Does anybody admit to knowing how to make full screen in Internet Explorer?
F12. No, with F12 step too far yet.
The answer is no.
F11.
It's not even this word, it's edge, right?
Sorry?
It didn't say edge. It's not even.
Nobody knows, so we have to look at it.
Was there a full screen icon when you move the mouse around in the corner? Oh, right. Yeah, in the left.
Left-hand corner.
Down in the left-hand corner. Down a bit. Line one.
Right.
There we go.
Hey. Okay, hello. My name is Jonathan Earl, and I make desktop Linux operating systems. And I work with KDE, which is the original community for making open source projects in a collaborative development way, using free software licenses and spreading it to the world. And we're 20 years old this year, and we get to travel the world and meet each other and have fun and spread freedom and create good code. So we get to go to, this is in Finisterre, on the very west coast of Spain and Galicia. And we get to go up mountains and explore the fresh air of Switzerland, and we get to go to Belgium and drink lots of fine beer. And we have good fun. And we make good software, or we like to think we make good software. And this is Plasma Desktop, which is our flagship product. It's the thing that we're best known for, is making a desktop that runs on Linux. This is an example of one of the hundreds of other applications that KDE makes. This is J'ai Compris. It's an educational application. This is it running on Android. And it has a dozen different educational games in it. And it's a really good example of kind of an industry-leading or field-leading bit of project that has come out of the KDE community, that has come out of the open source development method. Slides in the wrong order. So yes, desktop and Linux, they do it in Munich. The city council there runs my software on it, and they invite us out there every year. And the whole city council runs KDE and KDE software because they had a choice of, do we upgrade Windows XP to whatever the latest was and spend however many millions of pounds and give that over to an American company, or do we just hire some people to do it in our own city, keep some money within the city, which city councils of course like, and save them millions of pounds. So desktop Linux, anybody using? Yeah, good number. So that I'm impressed. So it hasn't taken over the world, but has taken over some interesting places like the Shire. Hobbits use it to code on their free software and get communications and well, be international freedom fighters as hobbits are. Weta Digital use it in New Zealand, and so they won't talk about it, but if you look on the occasional behind the scenes kind of DVD extra that Weta Digital do, then you can see KDE running there, which is really satisfying, and of course all their millions of servers that they render this on, or that they render Lord of the Rings and other films on, runs in our software. Google of course use it, both on their servers but also on their desktops as well, so we get invited out there. Again, they don't want to talk about it, so whenever I ask them about it, they suddenly go very quiet and say, well, I don't know, but by the way, do you know how to fix this bug that I'm having in this particular desktop that maybe somebody is having once? That yes. So they give us good smoothies, which is nice, but it's a shame that they don't talk about Again, places like the Islas Canarias use it, and all their schools and the universities use it. And again, for the same reasons, because it saves how many millions of pounds compared to if they had to use Microsoft software, because it lets them customize it exactly how they want to be able to customize it. And because if they have problems with it, then they can just invite me out for a holiday to sit on the beach, and then I'll fix their problems for them. And it's quite nice, good pro growth there. And Brazil as well, it's the biggest one. Brazil, every single school in Brazil, so millions and millions of people use it. But they never talk to us, which is very strange. So if anybody else knows of large or even small Linux desktop rollouts like that they don't want to tell me about, you can just supply me with beer and ask me for problems, and I'll get a hint, and you'll end up in the slides in a future talk. And CERN use it as well, of course. They use KDE software to create black holes and whatnot. And there's a sprint there just now that the Plasma team and other people are at, because they get invited out and said, great, you guys come together. And it's really a nice aspect of working on open source software is that if you do something that's useful, then people will invite you and pay for you to travel to interesting places like CERN, and in return they get to ask about particular bugs and whatnot. But the people that I care about mostly are the enthusiasts who just have a computer and go, I'm fed up with it getting too many viruses, I want to try something different, and install it on their computer and have a good time and end up happy and smiley like this. Because they go, wow, great, there's this software and it's just sitting there on the internet and you can just download it and there's no fear of being called a pirate and being having restrictions, and you can, if you're a technical minded person, then you can fix it, or if you know technical minded people, then you can ask them how to fix it, and you can contribute stuff, and if there are bugs, then you can report the bug and you can see the bug as it gets fixed. And that's really awesome until this kind of thing happens. This is KDen Live, which is the video editing application from KDE, and it got a release the other week, which said it has more than 20 issues fixed, and we encourage all users to upgrade. So a typical user would see that on an announcement, and they'll go, fantastic, that's just what I need to fix whatever taffy issue that I'm having to work around in this video editing program. And then how do I upgrade? Because as a project within KDE, we release the source code, and then we're reliant upon some other third-party project to package up that source code, compile it, make sure it runs, and then release it. So typically, when an application gets released by a developer like this, and they say everyone should upgrade, there's then a lag of several weeks, maybe several months, before the users can actually install that and upgrade it. And comparing that to Windows or Mac or Android or whatever, it's a pretty rubbish experience. And one of the reasons why only a quarter of the people in this room use it, and out there almost nobody uses it. And so you end up with a sad Conky Dragon. And there are however many dozen, hundreds of possible Linux distributions out there. But of course, even if you know your stuff, then these are pretty obscure stuff. So in terms of trying to answer the question of how do I get the latest bits of software, this isn't a very good answer, pointing somebody at District Watch and going, well, look at install the latest stuff, because it's incredibly obscure and faffy even to technical people, never mind to your average people who don't care about what an operating system is and shouldn't have to care. And then you get rolling distributions. So some Linux distributions said, well, great, if people want the latest and greatest, then we will give them the latest and greatest every day. So you can upgrade your operating system every single day. And these rolling distributions, they're pretty scary. If you care about having a running system that you want to get your work done on, even if you are the sort of person who cares about your operating system, which is a pretty niche market, you won't care about your operating system breaking because you have to install a new version of libc in order to get the new version of GCC compiler, in order to get the new module installed for your graphics card, which is an NVIDIA and whatnot. So that's a very difficult solution, which is great for the most enthusiastic of enthusiasts, but it's not typically that great for most people. So last summer I found myself somewhat busy. I've been working on a Linux distribution called Kubuntu for the last decade or so, and that's a variant of Ubuntu. It's one of the projects within Ubuntu, and it's a nice selection of software, which uses KDE software made by this original and greatest Linux desktop community within the bigger project of Ubuntu. But have something of a fallout with them because Ubuntu is made up of open source projects. It's made up of thousands, tens of thousands of projects that people write this code and then they license it under a generous copyright license, and then they're picked up by distributions like Ubuntu, and then Ubuntu ships them out. And everything in the Ubuntu archive has to be licensed, and it has to be licensed under quite. We have a policy to ensure that it is licensed under free and open source terms. But the company that's behind Ubuntu, which is called Canonical, they created their own intellectual property policy, and they said, oh, you have to have another license if you want to take Ubuntu and you want to make changes to make a derivative distribution. And this, of course, was a complete lie, because the entirety of Ubuntu is made out of open source software, which is already licensed by the people who actually write the stuff. So they've been very generous in licensing it, and then Canonical is saying you need another license, but there is nothing there to be licensed because everything is already licensed. So I spent 3 years trying to make this point, which I think is not that difficult. I think it's not that tricky to understand. It's fairly basic, but a lot of people get very nervous when they discuss copyrights and licensing, and they confuse it with trademarks, and terms like intellectual property are quite scary because they're overarching and very general, and they don't actually mean anything. So it's very easy for people to go, oh well, we'll just pay up for whatever license is needed. And so a number of derivative distributions like Linux Mint and others, who were using Ubuntu as their base but making whatever customizations and their own branding on it, they got told, well, you have to sign this letter and pay us a bit of money and restrict your own income and whatever else they had to do, so that you have this license for whatever it is. But they wouldn't say why you need a license. And those of us who spend our time reading copyright licenses and writing policies for it got kind of frustrated at it, spent 3 years trying to do it. Eventually Canonical required me to step down as being the leader of the Kubuntu project, which kind of shows how badly they were out of touch with their own community, because the Kubuntu project didn't have any leader and it had no leadership, and I deliberately ran it as a flat, non-hierarchical structure, just because I think that's a good way to run a project. But they were just trying to put me in my place, and after several months of me going, well, what does this mean? You need me to step down for something that doesn't exist. I kind of got the hint that my place would probably not be with Ubuntu. So I stepped away from that project because they were breaking the licenses of the project, and once you've broken the licenses of those projects by claiming restrictions which don't exist, you don't get that license back. So Canonical are continuing to distribute Linux and other software illegally, and it's a real shame that they're taking advantage of the community developers like that by breaking their licenses, by pirating their software, and that I get told that I'm a bad person for pointing this out, and I feel like, well, time to move on. So I moved on to Los Angeles here, and we hung around on Venice Beach and drunk hipster beer and went surfing on Marina del Rey. And we chatted about how we could distribute KDE software in a way which was a bit better than it was currently being distributed, in a way which is filled a use case which wasn't currently being filled, and we came up with a project which we're calling KDE Neon. So this project would firstly be a KDE project. It wouldn't be a third-party project. It wouldn't be some other distribution, and there are thousands of Linux distributions, and nobody's ever heard of most of them, and nobody particularly cares about most of them. So if it was a separate project, it wouldn't go anywhere, and there wouldn't be an advantage to it, because there's no advantage to being separate. One of the great advantages of open source is that you can be collaborative with the people who are making the software that you're using. So we wanted the project to be part of KDE, which is a project that's now 20 years old, but has never been able to distribute its own software. we wanted to have all the packaging in Git, which is nothing new, we already have. But I set it up so that it would be synced from Debian, which is where, if you know your Linux distribution, Ubuntu is derived from Debian, and as part of Ubuntu, we already did that packaging as part in branches in the Debian Git. But here we want to do them in branches which are synced with Debian, but which are on the KDE servers, and so any KDE developer can contribute to it. So if you're somebody who's developing an educational application, or the desktop, or a Bluetooth way, making sure your computer properly talks to Bluetooth, then they can get a bit frustrated when, after however many weeks, the distro eventually packages their source code, and there's a mistake, there's some file that's missed out some dependency that isn't there. And so it's a lot nicer to be able to get the people who are developing the software in the open source community to just be able to work on the packaging to allow it to ship in that open source community. And these packages would be built in a continuous integration, continuous development system. So we've got Jenkins set up, and it's set up to listen to the Git commits when people commit to their actual source code, and it's set up to listen to the packaging, so when people update the packaging, it fires up cloud computing services, and it fires up Docker, and it builds the packages. And here's a really good use case where a few years ago when Ubuntu started, it was really novel that they had Launchpad, the website that allowed anyone to create packages and use their Launchpad platform to distribute Linux software for Ubuntu. And at the time that was extremely novel, but since cloud computing has come along and since Docker has come along, that sort of stuff is relatively trivial to set up, because when you release a new bit of say KDE frameworks, which is the libraries that we have, there's 50 odd libraries here that needs quite a bit of computing resources to use. And if you're doing it on your own computer, then that takes forever. But if you're doing it on a cloud service, then of course you can just say, well, fire up 50 cloud servers and off you go. And if you're using it with Docker, then that easily allows you to create a minimal install, which is what's needed to make sure that the packages are built in such a way that there's no extra, it's recreatable. There's nothing in the build which is surprising or which is slightly different from the people who actually install the software. So it's really nice to be able to use this kind of buzzword DevOps compliant stuff to be able to create software in a relatively easy way that was a lot more difficult a few years ago. And this would have a developer edition. And by developer edition, I mean people who are already contributing to KDE source code or actively wanting to help out with testing and debugging and be part of the community. And when people use KDE software, they'll typically get it from a distribution, and that has several weeks lag between when it's actually released, and then they'll find a bug, and then they'll helpfully report a bug. But because there's however many weeks lag between the software being released and that bug being reported, it's probably not of much use, because the bug has probably already been fixed, it's probably already been found by somebody else. Using this, then people who are enthusiastic about Linux desktop software can just install it, and they know they've got the latest source codes, they know they have the latest fixes, and so if they find a bug, then they know it's still a valid bug and that it still needs to be reported. And then if the developer fixes that bug, an hour or so later we'll get packages, and then the tester can try it out again, and voila, you can successfully have a good round trip between testing, fixing, which is, as far as I know, not been done in the Linux world. And this is kind of DevOps-y stuff, which is pretty common now in most software development places, but Linux on the desktop is a little bit old school in this way. And it would have a user edition, which is built from released versions of the software. And the Jenkins instance will look for the newly released source code, and if it spots one, then it'll build it, and within a few hours you get your package. So that problem where the user was able to see the release announcement, but then not be able to install it for some weeks, should be gone with this. And that's that gives us a nice advantage over Windows, Mac, Android, iOS, or whatnot, where when a user sees an announcement, they can install it, but that announcement will be however many weeks after it's actually been set to ship, because they have to go through whatever process they have to go through to be able to ship it through an app store or even through their website. This will be available as soon as the developer says make it available. So we've got a package archive, and we've set that up, and people can install all the packages for it for KDE software. But we need a foundation, of course, because we don't want to be a rolling distribution where you have to upgrade your entire system every single hour of every single day, and where it's quite scary. We want to ship KDE software to people who are enthusiastic about that Linux on desktop by open source means. So the foundations we're using are Ubuntu LTS, because it's good technology, and it's popular technology, and it's good third-party support. It comes out regularly every 2 years, so there's no big upgrade very often, but it's within a time frame when the software is still usable after 2 years. It has enough hardware drivers and so forth backported that it's still usable. And then, of course, we want installable images. So there's not much point in just having an archive. People need to be able to install it. And admittedly, this is not going to be great for most end users, but I've decided that I don't much care about most end users, and whoever was talking about the year of the Linux desktop earlier, I've decided that it's not going to happen, because that's what I tried for a decade in Ubuntu, was trying to make a general project where the target market was everyone in the world, and that never quite worked. The target market here is for people who are enthusiastic about their operating system and open source desktop software. And the occasional large rollout, people like Munich we can work with to give them a specific version that they would need. So we would have installable images, and you would download it, put it on a USB disk, and then install that on your operating system, on your computer, to replace or alongside your existing operating system. So we decided all this in Los Angeles, and then we got invited out to Munich, and we drank lots of beer, as they like to give us in Munich. And we set to work on making this stuff up. And it's still an awful lot of it is under construction, but we do have packages which are available for that developer edition, so developers can install the latest code that has just been developed in the last 24 hours. And I'm working on installable images, and we're working on stable branches for the developer edition as well, because in most software you have a developer branch and a stable branch, and it's useful to be able to test both, so we want to build packages for both. And then we'll have user packages as well coming up shortly in forthcoming weeks. And we have some paperwork to fill in, which is why we still have a .uk domain name. But hopefully this should be finished tonight, and so we should get our kde.org domain name. So, Linux on the desktop is, I'm afraid it's not the year of Linux on the desktop, but this is a new way that fills a gap in the market, if you like, that wasn't being filled, where the software is being made directly with the people who are writing the code and being delivered by the same project, by the same community, to the people who are enthusiastic about that. But that's still kind of niche. There's still, you have to install your particular this particular Linux distribution. This stuff doesn't install on other Linux distributions. So looking towards the future, we would expect to have containerized applications. XDG app is one project, Limba is another one. And that's where you have a Linux container, similar to Docker, but a bit lighter, which means that the applications can just run on any Linux distribution. Because one of the problems with the Linux distribution, of course, is that there's a million different ones, and if you want to run a program or run something in a particular way, then you have to have the one that whoever compiled the software has. So this will be a forthcoming technology which seems quite likely to be able to solve that problem. It means that anybody can run any Linux application on any Linux distribution. And we're on various social media websites, including the ugly URL that Google Plus gives us. And I think that's it. Any questions? Yes.
There's been no release of Ubuntu in April, I believe. How much time it will take for Neon to be moved to that release?
So the question is, when the new Ubuntu long-term support edition gets released in April, when will Neon be ported to it? And the answer is that hopefully quite soon, after it's been released, as soon as it's stable. That's all we care about for Neon, then it's good enough for our use. Of course, we've never done that before, so I can't give any guarantees. And to some extent it shouldn't matter, because the important thing is this is for people who want the latest software from KDE, so to some extent we're not aiming at people who want the latest version of Linux, the latest GCC compiler. So that's not our primary concern, but yes, go quite quick. Any questions? Sorry.
I might be misunderstood how it all works, but my understanding is that you start on the basis of an LTS, Ubuntu LTS, and then the framework, so this is sort of a framework you're putting into place to be able to continually build specifically the KDE suites of software, and that despite the base Ubuntu LTS, the KDE part of the stack would be akin to a rolling release sort of setup. And so
I'm not calling it a rolling release, and I'm not calling it distribution, because it doesn't quite fit in with that, but it will have, that KDE part of it will be rolling, continuously updated, either as developer from the latest Git, or as user from the latest actual released software, but the base of it will be stable, so there's no risk of installing a new version of Postgres and screwing up your system. But, I've got a question in front.
How will these packages be available to end users?
How will the packages be available to end users? You go to archive.neon.kd.org, and it works with the normal Debian package system. You put it in sources.list and you can install it. And yeah, that's the best answer we have at the moment. And shortly, of course, we'll have installable images, so that'll be set up when you install the operating system.
Great. I'm pretty cool so far.
Great. Yes.
As I understand it, KDE is also underpinned by Qt or Qt. Do you use whichever version of Qt comes with the LTS distribution? Or do you...
So the question was, KDE software uses Qt, which is the widget library. And yep, most KDE software uses Qt, which is Qt, which is an excellent cross-platform widget library. And if you're developing your code in such a way that you want it to work on desktop and Android and iOS and Linux and Windows Mac, then that's the best way by far and miles to do it with Qt. So I'm a big advocate for that. And we do need to recompile compared to what's already existing in Ubuntu LTS. So we do that from released versions rather than from the Git versions. That's a bit too scary, but from released versions of Qt, we'll compile that. And if there's any other dependencies that the software needs to be backported, then we'll backport those as needed. But we'll be a bit reluctant to do it because that adds more difficulty and faff and a bit of risk to the user. But yeah, we'll do that.
Qt's been churning out new versions sort of through Qt5 onwards, but there was talk of a new Qt. The next one's going to be a long-term support one. Do you track them, or do you freeze on a long-term support one?
Do we freeze the long-term support release of Qt? And no, we wouldn't, because most KDE software will need the latest release of Qt because it uses their features pretty heavily. So no, I don't track that. We just use whatever the latest release is. There was a question in man in red.
From an end user perspective, how is this different from just having a KDE PPA?
So how is this different from having KDE PPA? One of the faffy parts about Linux distributions is that when you see an announcement like that one of you should install the latest version, then one of the answers is, well, you install this archive, you add this archive and then you install it from that archive. And that's quite faffy because you have to find the archive and then you have to know who makes that archive in order to know, do you actually trust this or not? And then depending on the archive, it may or may not be updated. There's still however much lag between the software being released and the archive being updated, and then the developer gets a bit bored and wanders off and then it doesn't work anymore. So the idea here is that it's all automated and it just gets built in Jenkins.
You could do the same thing. You could build all the KDE software that you want to build automatically and just push it into PPA.
Yeah, of course. So that's what we did. Project Neon was the predecessor to this, and it was part of Ubuntu. where we did build all KDE software and we put it into Launchpad and you could install it. But Launchpad is a bit slow and a bit, it's a bit slow and it's a bit laggy. It misses various features that we need in terms of quality assurance, in terms of when a package gets built, it now does various quality assurance checks against it so that us developers can go, oh yeah, there's missing stuff there. And it's not part of the KDE community, so it's not made by the same people who make the software. So the people who make the software can't go, oh, you've done a bad job here, let me fix that up.
That's an issue with Launchpad. You could have host external PPA do exactly the same thing, and you don't need to provide your own package distribution system.
Sure, and here's what we've done. So
this is actually it's a PPA basically.
PPA is a term that Launchpad created, so it's a term specific that it's just a package archive. Yeah. So this is just a package archive of KDE software and it's the latest stuff, but it's built with the community that makes the actual software. Manor Red. Blue.
Red?
You're next. Yeah, okay.
Yeah, so first to build on this question is then should you basically enable this in a normal Ubuntu installation or Ubuntu installation and have all the neon goodies without actually needing to install a new distribution?
Can you enable this in an existing Ubuntu install? Yes, that is the only way at the moment that you can do it. So at the minute you have to install some flavor of Ubuntu, Ubuntu 15.10, and then add this archive, and then install the meta package. And in future, as I say, we will also have installable images.
Another question, if I may.
I don't know, how's the time doing?
Last one.
Last one.
Sorry, just let's rephrase this by saying I haven't actually used KDE for about 2 years, but when I had used it, was always a problem, using a lot of memory. And I'm not talking about a lot of memory in actual terms, I have like 60 gigabytes of RAM, but on an old desktop, it used like 300-400 megabytes easily, right? So is it still the case, and are there any solutions to this? If you have a really old laptop, can you install KDE on it and can run it?
I'm going to start the answer by being pedantic. And you say you haven't run KDE, but KDE now is a community of people who make software. So KDE is those people that you saw on the earlier slide, and one of those projects they make is Plasma, the desktop. And you say that uses a lot of memory. When I first gave this talk at FOSDEM in Brussels in February, or in January, we had it running on an Odroid, which is a Raspberry Pi style ARM machine with very little memory and very little processing power, and it ran as good as anything. So one of the nice things about Qt is that it can, because it has to run everywhere on every platform, that's the whole purpose of the whole feature of it, is that it can nicely degrade depending on the hardware. If you don't have accelerated hardware, then it just quite nicely degrades and doesn't have so much transparency. And if you turn off the file indexer and the email indexer, then it can run on a software system like that, no bother at all. All right, thank you.
Great, thank you. Okay, there'll now be another 10-minute break, and then we'll have the Dockerizing talk, because I know he's here and fixing it.
The
Okay, because I think that was because also you have okay, super.
My favorite part is I took that battery life, which is only 11 hours. Yeah, and it's probably more than that as well, because when I take it what do you think I got it in house, other people got it in people.
I've never used
No, you can just not use the which is optional.
I'm not sure if I can be here.
What kind of keyboard is this?
Yeah, you have. You've always been pressing shift. Yeah, that's not a move. What?
Cześć. Jak tam? To jeszcze dużo.
If you want to buy one, get it for cheap, then I get
Za wszystko za miesiąc.
Are you serious? Are you serious?
This guy's gonna get the location. I just had to ask that myself.
There's a wee box under there.
Right, okay.
You heard that? Yeah. Sorry. It's not really for students or IT because they will take the whole knowledge during the studies. They contain some information. One of my email was just in case, but as I said, it's probably very lucrative for the students.
There are some people who just have like someone
government scheme really that we participate in.
Well, they
pay for well, as it says in the flyer, the training is paid by the government and half housed by the government.
He's on it. Not with these guys. He's on the team on the That's cool.
And it's your students have CVs or someone who's they find exactly interested in let's give it a shot. It's might be useful for someone to get through to IT Yep. The concert on Thursday in Glasgow last week.
They're likely pirate rock. Yes. Like pirate folk rock. It's quite rare.
Okay, right. Time for the second talk. Paul Dragunis is now going to talk to us about Dockerizing continuous integration and deployment. And over to you.
So, that's quite interesting in the last talk, because I was polishing off some slides and I heard the previous speaker talking about Docker and stuff like that. So, popping in to see that's interesting. So, yeah, quite curious what kind of audience we have here today as well. I don't want to teach you to suck eggs or make you fall asleep, but I also want to make sure that people who are interested and curious, that we don't skip over important information that you need to grasp, otherwise you may get a bit lost. So, just need a few raise of hands, a few questions really. At the moment, who is doing some form of testing their software? Yeah. Okay, fantastic. So that's about 80%. Of that automation, who is using continuous integration software like Jenkins? Anybody? Okay, it's maybe 50%. Who's using using continuous integration tools, but it's just not Jenkins? Okay, I'm going to shout out some names. GitLab. Any others?
VSTS.
No idea what that is. Sounds awesome though.
It's the studio online.
Okay, cool.
We
Any
have
others?
some plugin for TFS. To be honest, I don't even know what it is.
Right. Yeah, there's so many, there's loads of them, and it's not a new concept. New ones pop up to try and solve a new problem, but it's really continuous integration stuff on the automation, and it's just a way that it can run things for you without you telling the computer to run it for you, and you get some results back. So, just a wee introduction, because this is my second TechMeetUp. Came to the last TechMeetUp last month, and then Douglas and the guys asked me to do a talk here, so here I am. I'm from Glasgow, which you might have noticed, and I'm a full stack software consultant. So I do everything from DevOps and infrastructure to coding to like front end stuff. But specifically I specialise in quality assurance. So that implies quality is everywhere, right? It could be the quality of the code, it could be the quality of a lot of problems I face is people's opinion of quality is subjective. So someone's opinion of quality to a front end guy would be it was responsive and it works on phones. Another person's is it fast, is it secure, is it scalable? So I find myself doing a lot of work across a whole spectrum of software, and that's why I spend most of my time building, teaching, doing training at companies about pipelines, because that is effectively automating the whole process from A to Z. And that's kind of led me to do this talk. And if you want to keep in touch or stop questions, anything like that, that's my Twitter address and corresponding email. So, yeah, this is really just saying that these are the things I usually get myself into unintentionally, unfortunately, and that's really just I allow myself to do these types of things with CI, and that's why it's relevant. Automation, right? So automation is, so you have a command, and you can maybe sort of guess what that is. Not everybody will be familiar with Linux and stuff, but maybe you can kind of have a guess at that. What about this? Alright? Maybe you can guess at that. Maybe you can't. So that's what we have. That's the most basic form of talking to computers. And what we do is, now this, you can understand this. So rather than the first command, kill Java. I'm not being serious, but just a joke. But the idea is the first one was killing all processes in memory that have the word Java in them. Okay, so you can understand this. You can also understand something like this, which is a big long crazy thing, which was like finding Google referrals and then outputting it to a referrals text file. So for something else in the pipeline or something else next to take that file and do something meaningful with it. Also you can do things like this, which I've got. So you can order pieces. I love Selenium for that. I've got a wee Selenium script on my computer that you can put cron entries in. So also automation can be part of your life if you wanted to. I have a pizza or a favourite curry that I order, and I've just got a very small Python or PHP script, and it just uses Selenium, and it just goes to justeat.com, logs in, buys some stuff, and orders it. Could I go, I've got that's the same curry place, the same thing I order, so I've just got a button I press, boom, it's automation, right? So I'm sure you can think of some creative ideas of your own that maybe automation can help you. For example, remind you about stuff before you go to work in the morning. Take your tablets, shower. So yeah, automation can help you a lot. For me, I have a script logged into my bank and downloads a bank statement and puts it in a secure Dropbox for me every month, because I get sick of my bank charging me 25 quid to get a bank statement from 3 years ago. So I've just got a Dropbox on my statements again. So automation. But in terms of software business, potentially, we do it through continuous integration. And the definition of that, which again, because everybody here, because most people here are familiar with that, is just a repeatable, continual way to automate tasks and to get feedback on those tasks, like metrics and measurements and reports as a result. So that's CI. When you start with CI, the next stage is usually CD, continuous deployment or delivery. And they are distinct, there are differences with them. And deployment is that your pipeline continues to build regardless. It's doing it for you, it's building things for you without you saying, go and build this thing, go and try this thing. That's the idea of continuous. But the difference is that deployment is when you decide you want to go live, you want to deploy, you're in control. You decide when the next step is. It may not be going to production, it could be like getting some QA feedback or getting some manual testing on some software. And then when somebody says, yeah, that's good, or you get some sign off from the business about, yeah, that feature works okay, then you can press a button manually and it'll take you to the next step, and it might do a few automated parts and stop. Delivery is where your pipeline builds continuously, but once something goes green to a certain point, it's just going to go live effectively. You know, you're green, go to the next step, you're green, eventually, and you're live. Facebook websites like, say, Skyscanner, for example, they probably want to patch a bug and get to production fixed as soon as possible because now a volume of customers that they have. Continuous deployment is probably better for software houses that do things like sprints. So at the end of every week, you want to press the deploy button. You don't want to press it every time you push something to master, for example. So there's distinct differences, pros and cons to each one. So people say they can do continuous integration, that's one thing, that's just automating one part. But on a larger scale, it's about pipelines. And you can have data pipelines. In this case, we have automation pipelines. And that's just really steps going from one step to the other, to a point where they stop, you identify the fault, or they just continue on to a point where they shouldn't go any further. And what does a pipeline consist of? Just jobs and lots of them. As many what makes sense for you. But ideas, they've had their own single responsibility. So hopefully from this talk, either folks are doing CI or they have some kind of CI pipeline in place, so they're thinking about a pipeline. I'm sure everybody is one step of their experience or what companies are in, and I hope that either you get something from this talk that's improving your own pipeline. Also, we're going to move on to if you already have an existing pipeline, but you're already probably experiencing some frustrations with that pipeline, given the current the historical way we do pipelines and how Docker can improve that and alleviate these frustrations. So hopefully, you may get some value on how you would migrate your CI systems to Docker to get some further advantages. And even if you're not doing CI or you're not planning on moving your pipeline to Docker, you might learn a few things about Docker that will help you in some indirect ways. Okay, so what you put in your pipeline? Well, initially you need some code there, and you put something there. And in Jenkins there's a multiple SCM plugin, so you get, by default, Jenkins, most CI systems will give you what's your URL for your repository, right? So Jenkins has a multiple SCM plugin, you can get as many repositories you want, because your code may not live in one repo. And so that's one shout out to a plugin. Second step is you want to do the most efficient and quickest thing possible to get feedback as quick as possible. So that's things like lint checking. If somebody forgot a semicolon, you don't want to wait an hour for someone to forgot a semicolon, right? That's actually fucking insane, right? Especially if you can't even run your build yet and there's a queue of builds and your build hasn't run yet, you're waiting even longer. Also, unit testing is very important, and for me, my current customer, we have to run the unit tests inside the Docker environment because the unit tests need things installed on this system itself, like extensions to talk to Redis and other things. Whereas that doesn't exist on the continuous integration environment. That exists inside of the Docker's environment. So fortunately for us, we've got like a 3-minute time before we can even run unit tests. So if you get the opportunity to design your unit tests where you don't need, you can run it on like a base system. I recommend that without delaying it, right? Get your feedback as quick as possible even. And then you want to start performing thorough testing, and this is where the fun starts. And there's also different types of thorough testing. Initially, you usually start with integration, and then acceptance tests, like different variations of email addresses for people signing up and everything. And then you do end-to-end testing, which is typically using interfaces, right? Emulating what the users do, user scenarios, doing things like BDD, behavioral driven development, that type of stuff. And then we went on to do some security testing, XSS vulnerabilities. There's lots of tools out there to automate that. So we want to stick some of that stuff in your pipeline as well. Maybe at the moment you're just running tests, and if it's green for your tests, then you're like, okay, it's good enough. But what if there's been a regression or you forgot a validation check somewhere? Then security stuff might flag that up too. Also stress testing. If you've got the money for it and you've got the environments for it, you can with Docker especially, you can quite cheaply get new environments up and running quite quickly, and you can start throwing traffic at it as well. If you're not using Docker regardless, you have a dedicated pre-production environment. With your pipeline, I recommend that you have a job that throws traffic at it, and just to see if it doesn't fall over. Not anything crazy, just get 200, or what are the response times of my pages, my home page, or the web page you're testing against, or with the API you're calling. So I think I think the most important part of CI is, and even production, is logging. It's very underestimated, very underthought topic. You can't measure what you don't log. So if you don't log it, you have no idea what's happening. So having something there for logging is really important, because then you can create meaningful metrics about them. So when you're in your stress tests, you on a branch of your software, you've made a change to the sign-up form, for example. How many sign-ups can you do? When you made a code change, you can compare the main copy of your software, like a master branch, versus a feature branch, and you can see if there's any regressions in there in quality, for example. Is it insecure, or is it a performance issue there? So you can catch on a feature branch before it even makes its way into considering even merging it. Also, you can do these things in an automated manner that the computers are doing it for you, so you don't even have, it's before you even review the code. If people do pull requests, or they have code reviews, you can, the developer writing the code can push to their feature branch, and then the pipeline will kick in, and you'll get all these metrics and measurements before a human even looks at it. So it's a lot of meaningful, viable things here. So you've got a pipeline, you've got lots of many jobs. The reason having lots of many jobs rather than one big monolith job is that in pipelines, if you get past five steps and then it fails for some silly reason, and you can tweak it, you can fix that, you usually don't have to replay those first 5 steps, and you continue from where you left off and move forward. So it's about designing pipelines is very important. So if you forgot to install something on a box that you needed to run your stress testing, for example, you've already done your testing, your integration testing, and your QA and all that stuff, so you don't need to do that again. So by having it in small segments, then you could just replay those segments. Not replay the ones you've done, but start from where you want to start from. So a lot of people make that mistake about having 1 or 2 big main jobs to do lots of things. Triggers. So typically triggering is the way we do it. There's different terminologies in different CI systems, but in Jenkins, for example, we use the triggers, and that's how we glue them together. And we can have downstream triggers. So when this guy's job's done, you can say who you're going to call next. So when your unit tests are done, you can call your integration tests. Or when your integration tests are done, you can call acceptance tests. But also somebody tries to, you can create statements and logic between your triggers. So it doesn't have to always be a continual linear line. You can have branches and forks that do stuff based on certain conditions, like am I running my software against the master branch, or am I running it against the feature branch? Or is this branch a feature / branch, or is it a bug fix? So there's different use cases that apply to your companies that you want to have different triggers kick off in different circumstances. So being aware that there's a lot of options out there for that, and this doesn't have to go by a continuous line. That I see a lot of companies having one big line, and they're running stuff religiously because they don't have forking, and they're running things they're not even applicable, and it's just wasting time. Because money, right? So in upstream triggers, if somehow a job gets triggered, you can ensure that something has happened before. So if I want to run integration tests, for example, but the step before that is preparing the environment for integration testing. So you can also say, actually, I've got an upstream, and then that upstream can have an upstream, so you can get quite creative with this. So when you start kicking off your pipeline, there's 2 options. You can use commit trigger pipelines, so every time you push to a branch, any branch, you can have hooks that just kick in with Jenkins or start off. And that's good, but you need to be very careful if you've got the resources for that, or the resources in your pipeline. If people are pushing lots of commits to their feature branch, and you've only got like one build server, that may be stopping somebody from doing a deploy because you're pushing lots of stuff. And if I've got 10 developers pushing codes to it, that's 10 builds, and it can queue up quite quickly. So there's some caveats to think about using that. For me, I will sometimes just have commits triggered on master branch. That is more valuable to me, and then people can manually run their own feature branches if they like. And by manually running your own feature branches, Jenkins has a parameterized build plugin, which is really awesome, that when you trigger a build manually, you can ask questions to the person running it. Do you want to run the acceptance tests? Do you want to run security testing? Yes or no? Like drop downs. What branch do you want to run? So you can press build, and it will ask you what branch do you want to run. You just paste in your branch, for example. So it's a good use case of parameterized builds as well. And that will just trickle down through the jobs. So although you at the first job had some parameters, you could pass those triggers down. They just become variables in the CI system, like Jenkins. So if you've got branch name as a variable, and you ask the person running that in the first job, you can just pass those variables down through the triggers as well, so that you always know the context of that. And you get lots of these jobs, and they're a nightmare to even see what's happening, because you can't visualize everything in your head, and you probably didn't even build all this stuff. Somebody else probably built it. So it's good plugins and CI systems, Jenkins in particular. I'm using that because it's probably the most popular used tool. There's this one, this build pipeline plugin, and it shows you this is just the same job, the same build. You can run it over and over, but it has different steps, and you can see kind of naturally how your pipeline would work together very simplistically. And this updates in real time, so you could just watch it. You can stick it on your TV, for example, or you can just watch it. And the idea is that you can also just like replay any one of these wee guys. You don't have to. So Jenkins understands that. Is anybody using this? Anybody using this plugin? Okay, that's really awesome. There's another one which is on the right hand side. You can see it says trigger. So although these are all automated, you can stop. And then this one you can trigger to say deploy it to a QA environment, so like somebody can manually go press it or whatever. So that you can build your pipeline so that you can create a stop, and then you can manually say, right, let's go forward now. I'm happy with this for whatever reason. So you can have automated triggers, you can have triggers that are kicking automatically, you can have triggers that you press manually as well. And this plugin for Jenkins, you can visualize that for you and manage it. And this is it's called the previous one is called what's it called? But it's called the build pipeline plugin. This is also one called delivery pipeline plugin. Exact same thing. It's just a bit nicer, but you can watch in real time, and it will go on the left hand side. You do your compiling unit test, publish. And then go to the next step, and you watch it go red or green and green, but also you can manually intervene and press. So these arrows is you manually saying I want to go to the next phase, right? You can press that manual. So it's not plugin. This is the same plugin. It's just a different skin on it, and whatever, right? We'll take it point. So it's a really awesome plugin for Jenkins. I recommend you check out. But when you have all these jobs, and you have different jobs for different reasons, it's quite cluttered. So there's a photos plugin. Is anybody using this plugin at all? Okay, a few of you. You can group your jobs so you don't have this huge list of jobs down the screen, which I used to have before I discovered this plugin. So you can start grouping them now as well. So it's pretty cool. This has changed my life, literally. I've spent hours, which accumulate to weeks, which will eventually accumulate to months, maintaining jobs. So this may be a bit of a rant, but this is the job DSL plugin, and it's fucking amazing. You can describe what will happen in your jobs. Now, Jenkins jobs are really just XML underneath, right? But they give you a pretty interface that you can screw things up with, right? So they give you a little box and you can type in some commands, and you don't know who changed that command, and if you've got duplicate jobs that do the same thing, whatever, people can just go in and just change things, right? And then you won't know what they've changed, and you won't know what jobs are inconsistent, or somebody forgot a semicolon or a star, and all that nonsense, right? Also, if you've got, I've worked in companies where they've got like 200, 300 jobs, and you want to change, some retarded guy says, oh, let's change log rotation from 2 hours to every 10 minutes. And in Jenkins, the log rotate value is in every job. So you have to go over 200 jobs and change like a number 1 to a number 2, for example. So this plugin allows you, this is written in Groovy script, the plugin that converts it to the XML, but effectively it's just this nice syntax, and you can build your jobs here, and then you just and then just there's a wee job in Jenkins with the plugin. You say create my jobs, and you can create all your jobs, and you can describe them. And this can live in source control. This can live in a repository, so you can version control that. You can manage it as well. You can get PRs and reviews. If somebody changes their job in Jenkins, it's changed live, instant. This you can have. You can create a branch on the jobs repo, and you can get some reviews, collaboration, and then merge it in, and then get your jobs updated. So you can wipe all your jobs out and then recreate them all. And we're just talking jobs there. This plugin, see there's a function here called Maven, for example, right? So that's a Jenkins plugin. This job PSL plugin has functions for 140 plugins in Jenkins. So pretty much with a good degree of accuracy, every plugin that you're using for whatever technology you're using, like Ruby, Python, Java, that's part of plugins for it to do stuff like run things. And so the previous one was, okay, so we've got unit tests, right? So you can put your shell commands in. So rather than Jenkins, you have this big text area that you can just manually type things into. This is effectively the same thing, but it's managed and it's predictable. So hopefully you get the point. And I mentioned there's folders, plugins, and there's delivery pipelines, so that it's got functions for this too. So what you can actually do is you can build all these, you can build jobs in this DSL, and then you can make a folder, and then you can stick all the jobs in the folder, and then you can make a pipeline view of that stuff. That's like, and you don't actually do it. The plugins is free. So I really want to give a big good shout out to this plugin. So that's kind of like what, in my opinion, what makes a good pipeline. But there's problems with pipelines, and that is scaling is hard, and it's one build server per machine typically. And as a result, it's one environment for all your jobs to run in. So, say, even if you're using like Chef and Puppet to create your build servers, that's one server, and it can only have one version of like the kernel in it, or by example, one version of Java on it, one version of something installed, right? You're doing apt-get install or yum install, and that's on that box. So what if you've got a job that needs Java version X and another project needs Java version Y? You can't. They're different, right? You're going to get conflicting priorities, and it's a real pain in the arse to actually try and manage a box. So running integration tests on this box, you might need a database, you might need a web server, a caching server, and all these have to live in that one box as well. So managing that becomes a lot of effort and quite challenging. And they're all directly on that Jenkins box. So once you install them, that you can potentially screw up when you're trying to change a box and install things on it, and therefore all the jobs go down. Because there's like can't run Java or can't run Ruby or something. And as a result, you've got this Jenkins environment that has lots of things installed in one box, and it's inconsistent with production because you've got things in different servers. So for me, from a quality perspective, that's a big problem because people are like, yeah, work in staging, pass in CI, and you send it to prod, and it's not working. So that's problems, in my opinion, with Jenkins. I'm sure there's many other with standalone Jenkins, just like raw in the box. So here's this guy. About a year ago, I started really getting into this, and who's familiar with, I won't bore you with it, who's familiar with Docker? Who knows what it is? Okay, those of you who haven't, it is that, effectively. It contains something that's lightweight, portable, and distributable, right? It has all of its dependencies inside it, and that thing. In Windows, you've got an exe file. That doesn't have the environment, but it has all the code and dependencies inside of it, and you can take an exe and you can pretty much run it on any Windows machine, for example. So we've got your code. Rather than having your code on boxes, you can put this redistributable image. But where Docker takes a step further is you can put the environment as well, so you have a redistributable environment as well as your software, and that's one thing. And you don't need to set up environments because it's set up in the image and move the image around. Anyway, people ask me, so how does Docker work and all that? So there's this thing called libcontainer, and you've got your Linux kernel, and people say, oh, well, this container is using Ubuntu, and this container is using Red Hat, and how does that even work? And the answer is, well, they're all using the same kernel, and the kernel doesn't really care what OS, what distro you're using, so it does that. Also, you've got this thing called namespacing in C groups, which is in the part of the kernel, and it allows all the stuff that's running on the host machine, the machine you have, all the memory and the CPU and all the processes, they are completely separate from all the stuff that's running in Docker. So if you're running Ubuntu and all that, and you're doing things, that won't screw up your host OS because they're in separate namespaces and C groups, and also something called a geo. And this is kind of what it looks like. So I'll probably skip all these kind of basic intro to Docker stuff, but the idea is that you don't need Vagrant anymore, or your local environment. You don't need Vagrant on your local environment, and you don't need multiple servers to run different things in it. You can all run it in one box because they're all isolated by design, and you just have one OS, and you can stick all your containers inside of that, and they all use the same kernel, so and the same file system. So there's no abstraction, there's no delay between the kernel on the box that's running and your software. It's like as if it was just running straight on the box, but it's not. You've got isolation, which gives you the ability to change things and keep things independent. So let's get this. There's a thing called Docker Hub. So you Docker images of things. This is the official place where the official people behind the projects stick their official images, like Nginx or Apache or Ruby or PHP or Java, and you have versions. Versions that go, and you can have latest as well. So if you just want to say, give me the latest version of Nginx, then you'll just get the latest version, or 1.9. So that's where you go if you want to get images. When you're going to start using them on your computer, you use a Docker pool, and the idea, the syntax is the name of the image and the tag. So the tag is whatever you want to call it. It could be like unicorns if you want, but usually it can be anything like. So yeah, this is how you just a Docker pool on your machine, and there's the Docker run, and you've got a MySQL server straight up running, and you didn't need to install anything on your computer. So if when you're done with it, you just turn it off, and your computer's untouched. So in terms of CI, this is very powerful because you can run things on the Jenkins boxes, like you need a database, you need a cache, you need a whatever, and they're not going to touch the host itself. They're going to be inside the containers. So you can spin them up, run tests on them, do whatever you want with them, and then chuck them away when you're done. This is what Docker Pile looks like. If you want to make your own Postgres image, so you get the base Ubuntu image, and then you install some things like Python Postgres, and then you do some things, and then you expose port 5432, which is the default. So conceptually, that's kind of what a container is going to be. This is the definition, the description of an image, and then when you have an image, and you build an image, then you can run it, and that's called a container. This is an example, if you want to make your own web server image, you can call it like my application or my web server, and you can take a base image like PHP 7 CLI, and then you can install Nginx on top of that, and then run Nginx as like in the foreground, not static but in the foreground, and expose this image when you run it, expose the container as port 80. So it's kind of like you can take things, official images from things, and very quickly just add a few things that make sense for your project, and then you just build it, and that's it. And that code, the code that will be executed in that box will be the same on your development environment, it's the same production. Of course, there's a dev code, there's no change. It's built once, and then it's just redistributable. The idea of that is called unified architecture. So you don't have different machines with different things installed on them. You just build the image once whenever you want to build it, and you just put that image on any Linux box into a kernel, and it will be 100% identical. That's the idea of containerization, the benefits. So you've got a Docker file like this, or whatever, you've got this guy, and you want to build it, so you tag it. You do Docker build with a tag, you call it whatever, and you give it a version. And then once you built it, you can also, so this is Docker Compose. The Docker Compose is, it lets you describe the architecture. Say you've got production, and you want to start saying, oh, how do I bring all that production stuff under my own development computer? Typically you need like Vagrant, and you've got like 4 or 5 Vagrant boxes on your development computer, and it just like screws it up, and you need like 20 gig RAM and stuff. But with this, you don't. So you can have an application database and cache are all container names, and you just start building things down from the web like Redis and Postgres. In this case, we're using our own image that we built called TechMeetUp 1, and then we have our own application 1, which we expose on a port. And then to spin up these containers, either on your development environment or in Jenkins in a CI, to say I want to spin up these 3 containers because these 3 containers describe my software and all the dependencies that it needs. Docker up can compose up will just show you all the logs and in the foreground, and if you do -d, it'll run in the background. And you can, at any time you want to see what's happening, and it's spinning up in the background, you can take Docker logs, Docker compose logs, you can see what's happening. So, that's a really, really quick fly through of intro to Docker, because we don't have a lot of time. But this is how Docker hopefully encapsulates how it changes. Before, without Docker, Jenkins server would have there'll be a build server somewhere, and everything you need for your software will be installed directly on that box. And you have like shared resources and you'll fight for resources and stuff. Whereas the Docker plugin for Jenkins, it creates you a unique, an isolated build environment, and inside that you spin up all your containers inside of that, and then run all your jobs. And when the job is done, it just deletes it. So now you don't need to fight for resources on the same box, because you can have, and say it's the same job, so each like can be like a branch, like feature A, feature B, master, etc. So now scaling's a lot easier on the one box because they don't conflict with each other, and each one has its own copy of like the database and the cache inside. They can all communicate with each other, but they can't communicate with anything else, right? So it's secure, also it's reusable, and inside there is where you build your images, you build your Docker snapshots if you get a rebuild and you're happy with it. And the point where you build it here, it makes its way through production. So the point where you build an image here, you run a test against that image, and if it passes that, you know that the image you built there is the image that will run in production. From a quality perspective, that's massive, right? So that's why I really love Docker from a quality perspective. And this is a good overview of CI, not CD, just we want that very quickly, but CI is, so yeah, somebody triggers something, Jenkins kicks in, Jenkins does a Docker build, does a build, builds the image, containers are instantiated with the application code and all the tests are executed. And if the tests pass, then we push the image that we built on the bottom left, we push that image up. So the last step is we push the image up to something called a Docker registry. The Docker registry is anybody using like artifacts in their CI systems, like things like Artifactory and whatever, or RPMs, right? So the idea is without Docker, you've got something that works. You take a snapshot and you push it up to say a central repository, a central area, and you have versions of your software that you've got a snapshot and you know works. In the Docker line, this is called the Docker registry, and you can host your own internally. The Docker hub that I mentioned, the public one, that's also a Docker registry, but it's like free, anybody can put stuff up there as well. So you probably want to have your own software and your own Docker registry, and that is also ironically a Docker container that I just have running on a server. So, how do you push? So you build, but in CI it's useful because you can use these Jenkins bars. So now, you got TechMeetUp is the name of the image, and then you just change the version of that. So the build number is what will be the Jenkins build number. So you know that every time you get a build number, you look and say, okay, this build passed, and now you know the name of the fully qualified name of the image that you've built, what it's called as well, so you can correlate them. Things like when you build 25 was green, so we can deploy 25. So with CI you can get quite powerful and use these variables that are available to you in your CI environments as well. So this is what it looks like. So you've got tag, and the bottom you've got V1, V2. So the idea is that you're not duplicating any of your code because Docker uses a layering system. So you have the base OS, that hasn't changed. The tools like you do apt-get install, Python and Ruby and maybe some like Nginx, that hasn't changed. So the only difference between the last time you built V1 and the next time you built V2 is the blue and the green, which is the diff, right? The diff in code, right? So you don't like duplicate a lot because Docker has this layering system, which is pretty awesome. So that's why we do tagging. So when you get to the point where you have spun up an environment and you want to start running tests, you want to spin up your containers, right? So for me, I've got in my code repository, I've got like Docker compose.yaml by default, which is like for local development on my own computer, and then I've got like Docker compose.ci or .ci testing or whatever the weird scenarios you can come up with. So I just copy that to the root and then just Docker compose up, in the background, and it starts spinning up containers. Then I've got a suite that just runs integration tests, and it will talk to the application, and the application container can talk to the database container, and I can also put something in the cache, and I can just repeat that, and it's really in that little isolated land. I don't need to have like 3 different computers or whatnot. So you run integration tests, and that would be either go green or red. The next point is, if it has went red, where you say stop, we don't want to do anything here, that was a dodgy build. But if it goes green, then you do something called Docker push. And this is where you know that the image that went green, you're happy with it, you push it up to your registry, right? And that's your snapshot. And now it lives in the registry. So a little bit higher level view now. Test out your pipeline, containerized images, and then you get your on the left hand side you get your Docker push. So that's, I've got a green build, this is production ready code, sort of. Push out to the registry. And the idea of, on the right hand side, is just these other things are just doing Docker pulls respectively. So just like Git, right? So you're just pulling the same image, and you can pull it to any, now you can pull it to any environment you want. So you can pull it to your staging environment, preview environment, QA, testing, and prod, and it's the same image. It'll do the same thing. So that's higher level with the registry involved, because the registry is quite important. Stick a lot of hard disk space against your registry, because if you run out of disk space, you can't ship code to live. Find that out the hard way. You can production deployments get failing, or like why does the registry fail lower and the disk usage was 100%? Because we just kept pushing images to it. So I had my Docker push before I checked my integration tests. So regardless if the green in the build was green or red, I could just keep creating images and pushing them up to the registry, so that I moved them after the text say it was good or bad. Right? So don't make that mistake. This is the continuous delivery overview, and we're just coming to the end of the talk. But